So we're going to do a few more derivations here for inverse trig functions. So yesterday what we found out was that the derivative with respect to x of the arc sine of x equals 1 divided by the square root of 1 minus x squared. So we're going to do the same thing for the arc cosine. So let's say y equals the arc cosine of x. So what we did yesterday is we created this right triangle. And when we had the sine, when we were talking about the arc sine, we said there was some angle here, which actually, yesterday I called it theta, but today I'm calling it y. Doesn't really matter. Okay, so it's y. And because I'm trying to find the derivative of the arc cosine, I make the adjacent side x and the hypotenuse 1. And as a consequence, the other side is still 1 minus x squared, using the Pythagorean theorem. And the reason I choose, why do I make that choice? Because I have the arc cosine of x. So the cosine of x is going to be the adjacent over the hypotenuse, which gives me x. So that's the only choice that I can make, so that the argument of the arc cosine is x. If I chose x over here, I wouldn't be able to use that as the argument in my original equation given these relationships. Okay, so then what we did was we took the cosine of both sides. So we got the cosine of y equals the cosine of the arc cosine of x. And the arc cosine of the arc cosine of x, because they're inverse functions, is just x. So again, what we're doing, instead of using logarithmic differentiation, we're kind of using trigonometric, I don't think it's called that, but it's kind of like trigonometric differentiation. We're going to use the inverse properties of the cosine versus the arc cosine to help us to rewrite the original expression. Instead of y being arc cosine of x, the other way of thinking of it is the cosine of y equals x. They're the same. They mean the same thing. And at that point, we take the derivative. Once we simplified the left-hand side, is this thing working? Hello? Seems like I'm not. Hello? Oh, it isn't working. Wonder what's going on. Oh, it's because it's got turned off. Okay. There we go. Okay. It's like I don't hear myself. Yeah, I was asking Ms. Bowling if she ever uses this microphone, and she said no, she just yells. She just and I said I don't yell because I've got my headphones on. I didn't want to now next year when I don't have to do the recordings, since I've already done the recordings for doing an online class, I won't have to. Then I can yell. I can not use a microphone. Okay. So back to this. So now what we're going to do is we're going to take the derivative with respect to x of both sides. So again, because this function, cosine of y, is in terms of y, but we're taking the derivative with respect to x, we do what we normally do. We take the derivative of this as we would normally do. So the derivative of the cosine is negative the sine. And then we multiply by y prime. Yesterday it was theta prime. The derivative with respect to x of x is 1. So then we solve for y prime by dividing by this. So we get 1 over negative the sine of y. But based on our original definition, how we defined or how we specified this triangle, what we can say here is that the sine of x is equal to the length of the opposite side divided by the hypotenuse. So the sine of x is the square root of 1 minus x squared. So we get y prime is equal to negative 1 over the square root of 1 minus x squared. So we can say that the derivative with respect to x of the arc cosine of x is equal to negative 1 divided by the square root of 1 minus x squared. And if you compare that with what we had yesterday, you can see it's just the negative of what we got when we took the derivative of the arc sine, which again is not surprising because the derivative of the sine is the cosine, the derivative of the cosine is negative the sine. So they only did, like I said, it's not surprising they end up being the same thing, except that the sign changes from positive to negative. Okay, let's do another one here. And the reason I'm spending a lot of time on this right now, you're like, how many times can't you just show me the formulas? And yeah, the answer would be yes, but in chapter 8 we come back and we spend another whole section at least on using a similar kind of procedure, setting up the triangle, deriving the different trig functions based upon this particular right triangle. And so it's kind of a good thing to have beaten into your heads. So we're going to do two more. So let's say y equals the arctangent of x. So we make up our right triangle. Because I'm dealing with the arctangent, I want the tangent, the definition of the tangent, to be appropriate for this triangle. So I want the argument of the arctangent to be x. For that to happen, I have the opposite side being 1, the adjacent side being, x, the opposite side x, the adjacent side 1, and the Pythagorean theorem says this is going to be 1 squared plus x squared, or 1 plus x squared. So we can take the x squared, we can take the squared off of there, but that's, so you get 1, hypotenuse is 1 squared plus x squared, take the square root. Okay, so we do the same thing. We take the tangent of both sides. So the tangent of the arctangent, did I use, yeah, let me use arc here. I don't want to get the arctangent of x. So we take the tangent of both sides. So again, the right-hand side just becomes x. And then we take the derivative of both sides with respect to x. So the derivative of the tangent is the secant squared. We multiply that by y, and that should be y. So the secant squared of y times y prime is equal to 1. So y prime is equal to 1 divided by the secant squared of y. But again, coming over here, the secant of y, well, the secant is the hypotenuse divided by the adjacent. So again, it's going to be equal to the square root of 1, just 1 plus x squared. The 1 in the denominator I can get rid of. So based on my originally defined triangle, the secant of y is equal to the square root of 1 plus x squared. So I plug that in. So I get 1 divided by the square root of 1 plus x squared squared. Or y prime is equal to 1 over 1 plus x squared. And therefore, the derivative with respect to x of the tangent of x is equal to 1 divided by 1 plus x squared. And if I did the same thing for the cotangent, which I'm not going to do, I'm just going to tell you the result, it's going to be equal to negative 1 over 1 plus x squared. So you have the same kind of behavior. The derivatives of the tangent and the cotangent I mean, and that's, I made a mistake. It's the arc tangent. I didn't write that right. So let's fix that. Forgot the arc part here. So it's the arc tangent. Sorry. Same right here. Arc cotangent. Okay. So the derivative of the arc tangent and the arc cotangent are the same, except you've got a difference in sign. So the only one we haven't done arc cosecant and arc secant, so let's do that one. So let's say y is equal to the secant of x. So let's draw a triangle. The angle's y. The secant is the hypotenuse over the adjacent. So the other side is going to be x squared minus 1 squared. So that's how you set up the triangle for secant. And again, I forgot to put the arc thing in there. Sorry. Y equals arc secant. So now, so we got 4 out of 6. We've got to do the arc secant and well, we're going to do the arc secant, not the arc cosecant. So again, because I'm dealing with the secant, I need x over 1 to be the hypotenuse over the adjacent. Okay, so now what we're going to do is we're going to take the secant of both sides. So the secant of the arc secant of x is just going to be x. So we get the secant of y is equal to x, just exactly like we've done before. And then you take the derivative with respect to x of both sides. So the derivative of the secant is the secant of y times the tangent of y. And then you multiply by y prime. The derivative of x with respect to x is 1. And we solve for y prime. You'll get 1 over the secant of y times the tangent of y. So we go back to our original triangle. We actually already have the secant of y. I'm going to write these down. The secant of y equals x. And the other one we need is the tangent of y. And the tangent is going to be opposite over adjacent. So that's this divided by that. Or just the square root of x squared minus 1. So if I plug those back in here, so to get the derivative of my original function in terms of x, I'll get 1 over x times the square root of x squared minus 1. So that says the derivative with respect to x of the arc secant of x is equal to 1 divided by x times the square root of x squared minus 1. And you can do the same thing. So guess what the derivative of the arc cosecant of x is? It's going to be negative 1 over x times the square root of x squared minus 1. Now there is one caveat which we'll see here in a second. This is not entirely correct. So I'll wait for just a second. And I've never derived that one in class before, the arc secant. And I've got to, I want to just check something out here. Okay, well they don't tell us why. Okay, so let me just put up all the equations now. Oh, I guess I got to open up my notes here. So let's go to chapter 5, Oh, that's, yeah, this is the right one. So this is basically what I talked about last time. Oh, here we go. So these are all the derivatives of the arc trig functions. So you've got, notice they're using this chain rule version of it. I showed you 1 over the square root of 1 minus u squared, but if you use the chain rule, it would be 1 over the square root of 1 minus u squared times u prime. So these are all just the chain rule versions of the derivatives. And on the right hand side, you can see the domain, the allowable values of u in this case. So u can be between -1 and +1 because for the sine and the cosine, because the sine of x goes between -1 and +1. That's the range of the sine is -1 to +1. Therefore, the range or the domain of the arc sine is from -1 to +1. Same for the cosine. The tangent has a range from -infinity to +infinity. Therefore, the domain of the arctangent is also the same. And for the arc secant and arc cosecant functions, you'll notice they have this absolute value here, okay? And that didn't show up in our derivation. And to be honest, I can't remember. It doesn't say in the book why that's the case. They just say that's it. Okay. So just, I'll do a little research on that. But it turns out that when you have the arc secant derivative and the arc cosecant derivative, you need to put an absolute value on those. It probably has something to do with kind of the same reason that we have the absolute value on the logarithm. Because if you actually probably look at the area underneath the curve of these functions, for it to get to work out correctly for plus and minus values of u, notice that even the domain uses the absolute value. So the absolute value has to be greater than 1. So I'm sure it has something to do with to make it so that the sine, the area that we calculate, is positive when it should be positive and negative. But in the book they just give you the formulas. They don't explain it. I don't even know if they derived those. I'm surprised they can get away with that. Yeah, they don't actually go through those derivations. Okay. Anyway, while we're here, meaning this part of the lecture, not why are we in calculus, but why are we here? I'm going to write the corresponding integration rules. So the integral of 1 divided by the square root of a squared minus u squared du is equal to the arc sine is equal to the arc sine of u over a plus c. So the big difference here is the derivative involves 1, but the integration formula involves a, so that this number here can be something other than 1. And I'll explain later how that works, but for right now. We actually don't list the integral. We don't have one that corresponds to this one, because you can actually handle all integrations of this form by using the arc sine. You don't need to come up with the arc cosine. And you can see the only difference is one's positive and one's negative. there is a corresponding integration formula associated with this, which says the integral of 1 over a squared plus u squared du is equal to 1 over a times the arc tangent of u over a plus c. And then there's a corresponding one with the secant. So make sure I get the battle right. So if I come down to the arc secant, the integral of 1 over u times the square root of u squared minus a squared du is equal to 1 over a times the arc secant of u over a, and there's an absolute value somewhere in there. Let me find out what that is. Yep. So you have an absolute value on this part. You don't have to have an absolute value here, but when you integrate it, the answer has to be the absolute value. And make sure it's around the whole thing or just on, yeah, it's just the numerator. So it's the absolute value of u. And that's using the procedure, you know, if we know the derivative formula, we know what the corresponding integral formula is. And I think that's all the, I'm trying to think if I didn't bring my sheet, you know, your cheat sheet for formulas. I think pretty much we've covered every one that's on that sheet now. We've done logarithms, derivative of logarithms, the integral of 1 over x dx. We've done e to the x, both derivative and integral. We've done a to the x, both integral and derivative. We've done all of the derivatives of all of the arc trig functions, and we've done the integrals, three integrals that involve the result being the arc trig functions. So now it's just a matter of using those formulas. And some of them are easy because they fit exactly into the formula. Some we have to do some manipulation. It's kind of a precursor to what we're going to do in chapters, chapter 8. We're going to do a lot of this in chapter 8. Chapters 6 and 7 are kind of step away a little bit. But then we come back heavy into it in chapter 8. So, did I assign homework from this, from section 6? Yeah, I think I did. Okay. I'm going to go ahead and also, even though we haven't covered the material much yet, I'm going to go ahead and assign it because next Friday is the last day of class. So let me go ahead and give you that information. So let me open up section 7, and you can write down those problems. And then we'll work through some examples of all this stuff. So we pretty much derived everything that we're going to derive. We just need to Oh, you don't have the 6? Oh, okay. So go ahead and write 7 down. I'll come back and give you 6 as well. And I said incorrectly yesterday that section 6 was the last section. Section 7 is the last section. There are 8 sections in chapter 5. We're not going to do section 8. We don't have time this semester. So remember, for the physics test, you got to spread yourself out like we normally do. I'll put the tests up here. You can grab one whatever you want to. It's going to end at 10:30. I've got a telephone call I got to take at 10:40, so I got to get out of here. Okay, let's open up section 6 again. It must not be there. Let's see. Oh, okay, yeah. So you already saw that. So there's your section 6 homework. So section 6 is derivatives. Section 7 is integrals. So we'll do some derivative examples. Those are pretty straightforward. We'll do some reasonably straightforward integrals next time on Monday, and then we'll start getting more complicated. We may have to do a little bit of it at the beginning of next semester if I don't have enough time to complete it all the way. Okay, let's go back and find some problems to work. Okay, so here's the first one. What is the derivative of the function 5 times the arctangent of x squared plus 2x? So it's, what's the formula? Well, the formula says the derivative with respect to x of the arctangent of x is equal to 1 over 1 plus x squared. So you just use the chain rule. You'd say we're derivatives here. So f of u would be equal to no, actually we don't even need to use the chain rule. Do we have to use the chain rule? Yeah, we have to use the chain rule. Okay, so f of u is going to be 5 times the arctangent of u of x equals x squared plus 2x. So f prime of u equals 5 times 1 over 1 plus u squared, and u prime of x equals 2x plus 2. So the chain rule says that f prime of x equals f prime of u times u prime of x. So we plug that in. So we get 5 times 1 over 1 plus u squared times 2x plus 2. So this is f prime of u. This is u prime of x. And then you plug u back in. In this case, we can't do a shortcut. So you'll have 5. I'm going to move that to here. Divided by 1 plus u is x squared plus 2x. So that's u. You square that. And then you multiply by 2x plus 2. And then you'd multiply 5 times both of those terms if you wanted to. You'd have 10x plus 10 divided by 1 plus the quantity x squared plus 2x quantity squared. So we just have to use, it's not, it ends up with a weird looking expression. You wouldn't expect that would be the answer, but it is. So if we have the formula, it's just a very straightforward application of using the chain rule. We use the formula here. Instead of x, I put in u. I look at the formula, write down, put u instead of x in there, This part's just a normal polynomial differentiation. I write out the chain rule, plug it in, make it in terms of x, do a little simplification. That's all there is to it. Okay, let's try another one here. Actually, I'm going to make one up here that's not involving the arc secant. So let's say f of x equals 3 times the arc sine of x squared minus 1. So what is f prime of x? Question mark. So the formula, the derivative with respect to, I'll write the formula down for you. The derivative of the arc sine of x is equal to 1 divided by the square root of 1 minus x squared. So you should know enough how to do that. I've given you the formula. Just apply the chain rule, just like we did in the previous problem. So u is going to be x squared minus 1. F of u will be 3 times the arc sine of u. To me, these are kind of so easy they're boring. It's not really much challenge to it. If you had to memorize the formulas, that would be the only challenge. Now, if anybody is going to the Clifton Forge parade tonight, I know some of you are because you're in it, and you think, oh, let's go over to the Masonic Theater to hear our band play. I think we're going to start at 7. Just to be warned, we're just doing a sing-along, so they're very simple arrangements so don't be disappointed. You know, like that's all you guys do. So we have these simple Christmas carols. It's the ones the Masons always play at church, except there's always this variation, which is the more interesting part. We're not even doing the variation because it's for singing. So we're only doing it. So don't go there and say, "Oh, these guys are just boring." So it has a purpose, which is for you guys to sing along. And then you can watch The Grinch Who Stole Christmas if you want to stay after that. I'm not staying. I'm leaving. Did anybody decide to still go over to Lexington today? Yeah. So I'm going over there. Not sure exactly what time. Oh, I already did that. Okay, so there's your answer. Anybody got any questions? about what I did. Somebody may say, should I multiply this out and simplify it? And the answer is, nah, you don't need to. Okay, so that's arc sine. Here's one more. So the arc's, what's the derivative? The arcsecant of the natural log of x. Not as difficult as it seems, right? F of u, arcsecant, oh, and the formula, yeah, you need the formula. So the formula says the derivative with respect to x of the arcsecant of x equals 1 divided by the absolute value of x times the square root of x squared minus 1. So there's my answer. So what I've done, I've taken the formula, which I have in terms of x, just put it in terms of u. So that's the derivative. The derivative of the natural log of x is 1 over x. Train rule, plug them in there. Substitute the natural log of x for u. And then I finally put this in the order. X times the absolute value of the natural log of x times the square root of the natural log of x squared minus 1. So before we finish for the day,